Projectiles question 1. A car drives off a 15-metre cliff at a speed of 20 meters per second. Calculate A, the time of flight of the car. Well, it might help to draw a simple diagram. So here's the cliff, which is 15 meters high, the car travelling at 20 meters per second towards the cliff, and it's going to take a path something like this, and that will be our horizontal displacement s subscript h. Well, for any problem involving the equations of motion, it's useful to write down SUVAT, where s is the displacement, u the initial velocity, v the final velocity, a the acceleration, and t the time. When it's a projectiles problem, we can do this for the horizontal direction, and in a moment we'll do the same for the vertical direction. Well, we're not asked yet for the horizontal displacement. We know that the horizontal initial velocity is 20 meters per second, and as there are no forces in the horizontal direction, the final velocity will also be 20 meters per second, meaning the acceleration in the horizontal direction is 0, and we don't yet know the time. If we just gather our data for the vertical direction, we know that the vertical displacement will be 15 meters. That's the height of the cliff. U, well, initially it has 0 vertical velocity. V we don't yet know, but we do know that the downwards acceleration is that due to gravity, 9.81 meters per second squared. The first thing we're asked to find is the time of flight of the car, and this will be the same for the horizontal and for the vertical components. When the car hits the ground, it will stop moving in both directions. The equation of motion we're going to use is s equals ut plus a half at squared. When looking for which equation to use, it must contain the thing we're looking for, and it must only also contain things we have. We can never find two unknowns from an equation of motion. I'm going to use this equation in the vertical direction because here my initial velocity is 0 meters per second, meaning this term disappears, and I'm left with s equals a half at squared. S I know as 15 meters, a I know as 9.81 meters per second squared, and t I want to find. I can rearrange the equation as t is equal to root 2s over a. All I've done is move the a across and down, move the 2 across and up, and square rooted. Putting the numbers in, I've got 2 times the vertical displacement of 15 meters over the vertical acceleration of 9.81, and square rooted, this gives a time of flight of 1.75 seconds. I can now put this information into my table of data, because it might come in useful later, and move on to part B, to find the distance from the base of the cliff to impact. Now I have the time, this is easy. I have the horizontal velocity, I have the time, and displacement is equal to velocity multiplied by time, and in the horizontal direction this is just 20 meters per second times 1.75 seconds, giving a horizontal displacement of 35 meters, which I can now add here. Part C asks me to find the vertical velocity on impact. That's this term. Now I'm going to use the equation of motion v squared equals u squared plus 2as. I could equally use v equals u plus at, but that would use my rounded figure of t here, so I might as well use all the data I was given. This then gives v as the square root of u squared, which is 0 squared, plus 2 times the vertical acceleration of 9.81 meters per second squared, times the vertical displacement of 15 meters, giving a vertical velocity on impact of 17.2 meters per second. That completes the final part of the jigsaw here, and now I can move on to part D, I'm now asked to find the impact velocity. This needs to take account of the horizontal and vertical components. So I have a horizontal component of velocity of 20 meters per second, a vertical component I've just found of 17.2 meters per second, and the resultant of those I've called v will be down here. So to find v by Pythagoras, I know that v squared is equal to 20 squared plus 17.2 squared, giving a velocity on impact of 26.4 meters per second. I also need a direction, as this is a vector quantity, so I've written here angle theta, and tan theta is equal to opposite over adjacent, in this case 20 over 17.2, so theta is 49.3 degrees. So a final statement, the car hits the ground with a velocity of 26.4 meters per second at an angle of 49.3 degrees to the vertical.